Native database for unstructured data from Ramon Navarro Bosch.
Hello. Thank you. Thank you so much. Okay, so I'm going to have a talk about my new project, my now shiny new project. Just to be clear, I'm not going to talk about Guillotina. So, well, there is one slide that appears, but it's not. Guillotina is a really working framework, and I really hope that all of you switches your backend to Guillotina. But it's stable; it's being used quite a lot, so it's great and has a good life. I'm going to talk here about another database that it's NucliaDB. And in order to talk about NucliaDB, first I want to talk about what search means. It's about searchability is around all this conference. I think I've heard the word Elasticsearch or Solar at every talk, nearly. So that's definitely a problem that we are having as a community, as a product, as a business. Searching, it's been complex. It's never been fully solved. And at Plone, we have the Z catalog that offers BM25 with the text indexing. There are a lot of good solutions that offer typo tolerance, like the type settings that Andreas pointed out. There are Elasticsearch and Solar for BM25, scaling things. A lot of amazing tools on the table. But what they do is mostly do keyword search, and they do fuzzy search, faceted search, and filtering most of the times. Here, I'm going to talk about the next generation of search. So search, it's not I search for a word. For me, searching is finding something that I'm looking for, and maybe I don't know which word the guy used. Or maybe I don't speak the same language that they used to write down, that kind of thing. So the question is, search is the center of all the knowledge that we have on our sites, on our databases, and it's a really difficult problem. So, Nuclia. Before talking about NucliaDB, let's talk first about Nuclia. Nuclia is a European startup backed by VCs that it's based in Barcelona, and it's full remote. We are building a SaaS platform and a database, the NucliaDB, because what we want to do is to solve first search on unstructured data. Unstructured data is something that maybe it's a complex concept, but at the end it's files. At the end is a link. Anything that has not a really proper structure that you really know what you want to search, no? Oh, I want to do a calculation or any kind of easy thing that you do with SQL. I'm just talking about any binary textual information that has not a proper structure on it. We also want to be able to understand any kind of information or data and provide the optimal searchability on top of that data. We want to do this using the state-of-the-art NLP models, all these foundation models, building on top our own product to provide classification, entity detection, anonymization, super important for the GDPR use case, text generation, question answering. We also offer NucliaDB as a SaaS, so you don't need to install yourself. It's the same software, I can promise you. You can see in GitHub Actions the triggers that deploys the database on merges to master, on main to production. And at the end, we want to make searchable what's unsearchable right now, reinvent the search. So in order to do that, this is our goal, this is our mission. We needed to first build a database to store it. So we built NucliaDB. NucliaDB is a database built with Python and Rust. Python because I like Python. I think that it's an amazing language, and it's really goes super fast to develop anything. And Rust because we also need to run fast things, no? And Elasticsearch and Solar uses mostly Java. TypeSense is C. But we discovered that on Rust, we find a really good friend for building the indexes that needs to go super fast. It's a database that is extensible, cloud native. It's a replacement for Elasticsearch and Solar in most of the use cases. mostly the use cases that are knowledge search based. Because Elasticsearch and Solr can be used for logs searching, for security checks, for a lot of use cases. That is not the one that we are trying to find out. Is that you have knowledge and you want to find your information with a good search engine. So then, what we have, what is NucliaDB? As I said, it's Python. It's mostly based with Fast API, pedantic models, and everything that it's internal, it's using protobuffer and gRPC. It's open source. We are using Affero GPL 3 license, cloud native. Everything it's able to be deployed with on Kubernetes and Docker. We built automatically Helm packages to deploy monolithic, fully distributed versions of the database. We support TAKB, a fully distributed key value storage for scaling the main storage. Redis, if you want to have something smaller that fits on a single database. And we are also supporting local. For blob storage, GCS, S3, Azure file system. And for commits, we are using Jetstream commit log. At the moment of searching, what matters is the indexes. No? So here the indexes are built on top of Rust, and we have a full text search index, a fuzzy search index, a faceted navigation search, an approximate nearest neighborhood search, that it's the semantic search, a knowledge graph search engine. All these engines together are bundled on NucliaDB, so you can have multiple ways of doing your searchability. How this database plays with the platform that we have with Nuclia. So NucliaDB is the storage layer. You store everything on the database in order to provide searchability. And Nuclia provides you a layer on top to transform any file or any kind of link into something searchable. A PDF, a video, and a link to a HTML page, a text, wherever, a conversation. Everything gets merged, gets extracted, processed, understood, so you don't need to worry about the hard part that everybody, I think that most of us had sometime deployed a tick somewhere to extract the text of a PDF, or we needed to integrate that with Elasticsearch. So this is as a service, you don't need to worry about anything. You just send the file and you get the data already processed. And if you want to provide the proper searchability on top of that file, then you use NucliaDB. On our cloud, we are not storing anything. If you are using NucliaDB locally, we are using just the cloud to process the file, extract, or to train the models that you want to do with your own data. Once I explained this thing, the question is, okay, but can I use NucliaDB standalone without your services? Yes, you can do it. But you need to inject the text and the vectors and every kind of information that you want to add by yourself. That's up to you, how you want to extract all this kind of information with the state-of-the-art libraries like Hugging Face or any of these other extraction and machine learning libraries. What else? How we deploy it. I wanted to talk about deployment because we put a lot of effort to make it super easy to use it. So NucliaDB can be installed just in your local laptop, and we use only your hard drive, nothing else. No database, no Postgres, no Redis, nothing else. Just your file drive. This is not designed for a production environment, it's just designed for testing purpose. It doesn't have a strong consistency on the transactions because we are just storing everything on the file disk in different folders, but it's really a good, great experience from the API perspective and the searchability perspective. To test it, you just pip install NucliaDB, you start it, and you're going to start using the API. I will do a coding demo later. Then we also deliver the Docker images already prepared and optimized. We also, as there are all the indexes that are built on Rust, we are building all the binary for all the possible architectures, including Mac M1. So there is no friction to install it on your laptop. You need Python 3.8 upper. Yeah. Then this is the standalone deployment. We have 3 main folders. One is the main, where we are storing the objects, what will be the ZODB on Plone. The blob storage, the blobs, we all know what's blob storage. And the node is where we are storing the indexing information. So you can have just 3 different folders, and you can run on your local disk. Then you can also move to use Redis as the main database. It's super fast. It's simpler. It's more monolithical in terms that you only can run in one Redis right now. But if you want a fully distributed architecture, this is the architecture we have on our production environment, and it's able to scale. Well, we didn't reach yet the limit. It's each one of these. The fast API is splitted already on the code with the search, the writer, and the reader components. The ingest is the one that does the transactionability. We are using a project from nats.io that's called Jetstream for doing a transaction queue, a commit log queue. So we are making sure that everything gets transactional. And we are using TAKB under the hood to store the key value, GCS or S3 for storing the blobs. And then our nodes. The node is our index components that are built on top of Rust. Has a cluster management protocol called Scuttlebutt that creates the cluster using this kind of consensus algorithms, distributes the shards across the different nodes, and then it's able to scale, and you can add more nodes as you are scaling, and it scales horizontally. What else we have out of the box on NucliaDB? A Jagger support, so the guys who like distributed tracing can use it just installing it, pointing to your Jagger, and it sends all the spans of everything, all the interconnections about everything. Prometheus metrics out of the box with all the same metrics that we're using for our production environment are all here. We have a Python and TypeScript client to interact with the database if you don't want to talk the HTTP protocol. We also have a library for data scientists in order to build their own models on top of the database, so it already returns all the information in a proper format. And we have export and import tools, so you can export all the data from a database and import in a new one, etc. What kind of information we are able to store right now? We have fields supporting, I didn't say that, NucliaDB is a schemaless database, so what matters are the fields. So the text field or HTML or Markdown, binary files or any link to an external binary file, HTML links or conversations, date times and labels, and layouts. Layouts is kind of a generic box where it's designed to store any kind of JSON layout that you want to store and index properly. So maybe Volto layouts can be stored there someday. And I'm going to try to do a demo, a live demo coding. That's going to be super. This work? This works? Yeah. Okay. Okay, so in order to show you this demo, I will require these packages, NucliaDB package, NucliaDB client, that is the client that we are using to connect to NucliaDB. As I'm going to do a full open source demo, I require something that creates vectors. So I'm going to use a library that's called sentence transformers, a request, everyone knows, a beautiful soap to clean up some code, and some debugging tool, okay? So the first script that I'm going to execute it's a script that, you see, okay? Yeah. I'm going to load a machine learning model that just converts text to sentences. I'm going to run NucliaDB in my local laptop, and I'm going to create a client that connects to it, create a knowledge box. A knowledge box is what we call a container. The Plone site will be, it's the main big object container for everything. So we create a knowledge box. Then I'm going to get all the audiences from these Plone conferences. I'm going to create as labels on the system. And then I'm going to get all the talks that we have at this Plone conference using the REST API. I'm going to get the title of the talk, the body of the talk. I'm going to create a resource on NucliaDB with the code of the session, or with the classification of the session, with the body of the talk and the title. And then I'm going to parse the body to remove HTML tags and add this as text to the index. I'm going to create the vectors and push the vectors on NucliaDB. This needs to be done because we don't have any other external system, but right now, just for demoing purposes, it works. It works well. So, first of all, I'm going to run NucliaDB. I think I have just recently. As I said, you run NucliaDB. I didn't install NucliaDB, but I can imagine that it's simple. Blob, main, node, and I also add info, so you can see some debug information coming out. And this opens as creates the folders, creates everything. As it's designed to be super scalable, you will see a lot of debug information about partitioning, scaling, and these kind of things. And now I'm going to execute the conf upload OSS. As I said, this script is going first to load a machine learning model, already loaded. It's going to create an ontology saying that the talks has user, integrator, designer, developer, and sysadmin labels. I'm pushing this to NucliaDB. And now it's getting all the talks that there are on this conference, and it's going to push them to NucliaDB. It takes approximately 2 minutes to process all the talks and push, because it's my laptop is now getting the text, creating the vectors with a machine learning model. It's lucky that it's a fast laptop, because this takes 45 minutes to do this demo on a standard laptop. So if there is any question, meanwhile, we can wait. Kim? It's an M1 Max. And Metal has, they have a good driver for M1 for machine learning. So it's using all the GPUs at the same time. It gets quite hot. But it's the only way to do an out-of-the-box example. The good thing about this NucliaDB is that, thank you to Eric, now we can show things. And as he says, if you don't show something on a browser, it's not useful. So now we have this nice UI when you install NucliaDB. That it's super simple. It lists all the knowledge boxes that you have on your database, and it gets to you the widget, our widget, that it's a Svelte widget that you can deploy wherever you want and connect to any knowledge box that you want. And you can start searching for things. For example, I can search for Victor, no? And as you can see, it's pointing me out that Victor appears on a text for state of the art, and as it's fuzzy search, it detects vectors, also maybe something that you're looking for. Super simple. It's also kind of 2 milliseconds time of querying. It's using the Rust index at this moment. So super simple solution. But let's see the power of machine learning, but with this solution. In order to do this, I'm going to imagine 3 queries that I'm going to do. How to migrate lots of pages super fast, moving from a draw to a project, and compatible framework with actual API. No? These are 3 queries that the user may want to do. I'm going to use the same model as before, and I'm going to run this script that just queries with the vector and the query at the same time to get the answers that we are looking for. Okay, so, and we are just going to show the answers. There is nothing strange on this script. So, I'm querying my local NucliaDB, and it says, how to migrate lots of super pages. I was surprising because I was expecting another title, and it looks like the most close is a really good one. How we created, deployed, and updated over 200 websites at IMEO with no downtime. It's really the closest title that I could imagine that I could find. Do you see it properly? Or yeah. On Fuzzy Search, you will find different things because, of course, there is any of these words is on the title. But it's what I was looking for. I'm finding the information I was looking, but I'm not finding by Fuzzy Search, even for full text search. Moving from a draw to a project, there is a body on a talk that says, we will discuss our approach on how to tangle the development of new Volto, transforming a design into a work plan. It's completely different from what we are searching, but it's exactly what I was looking for. This is searchability for me. And we can go on with a lot of multiple examples. Okay? So this is the magic. This is what search needs to be from the user, because he needs to find the information that he's looking for. Okay, now if you, I think I have a few more time. I'm going to stop this database, and I'm going to start again this database with an API key you could get on the cloud. Just go to nuclia.cloud and sign up, and you get an API key for free. And yeah, it's super simple. And now I'm going to start my NucliaDB with an API key of our API. And now, instead of going through pushing the talks from the Plone conference, I'm going to push a PDF, a Plone brochure PDF that I found somewhere. I was looking some PDF from Plone. Is this PDF here? I don't know if you are able to see it. It's quite an old one. I'm going to push this PDF, and that's all. It's just a post to upload this PDF, nothing else in this script. Okay, so takes a while to upload. I hope that my internet connection is okay. I tried this twice and it was super fast. Yeah, it's created. And now this file has been sent to our processing, to our SAS to get processed and to extract everything. And it takes more or less 1 minute because I'm using the shared queue and there is a lot of traffic right now. But I will come back later to here. So let's get to the presentation. As I said, if you want to use with Nuclia Cloud, you just need to have the key. You get extracted text, vectors, previews that will be delivered. So you push a PDF, we are cutting it. If you push a video, we are pushing the streamable version of the video, etc., etc. All the vectors. And will allow you to train new vectors. And because I'm here, I wanted also to talk differences between Guillotina and Plone with Nuclia from the internal perspective. I moved pickles to protobuffers. So now instead of storing pickles in a database, I'm storing protobuffers. It's easier to be used by other people in the world. But it's more or less the same kind of concept. I also have a concept of behaviors inside the database, but it's all protobuffer based. Traversal to flat. We don't want to reinvent the wheel, and most of the databases nowadays are flat and this kind of thing. The security can be built on top of that using filters, like, for example, any of the other competitors. And so the main structure is all flat. So as I said, the security is not on the objects, it's on the headers of every request. And the main element is not the object, it's the field. So we are schemaless, and at the end what matters is how many fields do you have on each resource. Contributions are super welcome. It's an open source project. There is a contribution agreement that you need to sign up, but that's all that is required. We want to have a really good local database for just local installations. We would like to support SQLite or ZODB, for example. We would like to be able to index Volto layouts, if it's possible. So if somebody wants to contribute adding this to the code, it's super great. More examples with NucliaDB client library. We would like to have an index to support events, so we can have recurring events. And any other idea is welcome. I suggest you, if you want to contribute, participate, know more about the project, just point to the QR or this URL is our Discord. It's open, and you can join and ask anything that you want. And now let me see if as it happens, the network connection is not properly. I had a B plan for. This has already processed, so it makes it easy. And now imagine that I'm a Catalan guy, that I want to search which databases uses Plone, no? And it looks like the sentence, it's in English, but I searched it in Catalan. Just Victor can confirm this means what databases are in in the system. And you have the first best semantic search result. What databases does Plone integrate? The question is that pinging it there, you get the thumbnail of the page that you have, and then you can see the answer here just close to the PDF. You can also see all the entities that we detected, for example, all the possible organizations that are on this PDF. Then we do a summary of it, and we also get all the text by paragraph, split it from the PDF so you can have searchability. This is what you get out of the box, just using the API on the same database. And yeah, that was mostly everything. Just to say, it's slow. We are hiring, so if anybody wants to, go fast. We are hiring, and if anybody wants to send their CV, we are looking for Python and Rust developers, and nucliadb.com/careers. And thank you, and if you have any question, more than welcome.
Hi. You were mentioning at some point, but not in this presentation, in our discussions, that you also have generative answering, right?
Yeah.
But you didn't demo it, correct?
I didn't demo and propose because I want to show things that are really useful, no? And the question of question answering is that there are two ways of doing it. It's using VM25 for searching the best ones and then just choosing with a squad. This approach, it's super interesting, but it's super CPU consuming, and it's the value that you're returning is just helping the user to find out on the text where is the answer that you're looking for.
Yeah.
And if you already have the paragraph that is a really small amount of text, it's easier for the user than just showing the answer, because then there is no context. So we went through that process, that phase of doing the end-to-end to 5 as a squad, and we decided to stop it. And now we are in the phase of having more text generation answers, which brings more context, and it's super interesting. It's just the amount of CPU power that you require right now, it's not scalable enough to provide this as a SaaS platform. So we are evaluating, distilling the models to make it useful, and right now it's too much complex to provide as a production environment.
Okay.
But we will eventually, it's one of our tasks on the roadmap.
And I was curious about the code samples that you showed. I'm wondering, so you're using the same model to encode the queries and also encode the text?
Yeah, in this example I did from open source, we are using this paragraph phrase milliml LSys v2 for creating on uploading, and the same for on the querying.
Okay, and do these models usually assume a certain maximum document size, a certain sentence? And
that's why I choose the summaries of the talks of this, because for the demoing purposes it's great. That's in our cloud we split everything in paragraphs, and paragraphs and sentences are our units of working, so it's feasible to convert that to vectors.
Okay, cool. Thank you.
More questions?
Yes, for Kim. Question.
We have a question from Discord. Arki asks, how does NucliaDB perform while ingesting documents that are multilingual, English and one other language? Searching is difficult with documents that contain more than one language.
Yeah, that's a really tricky question. We allow the user to define which are the languages of the. In these cases, you need to define that the document has 2 languages, and we will process with both language processors.
Okay, thank you. Sorry.
I think it's an obvious question coming from me. Have you done this with Asian languages and languages without white space?
Sorry, I didn't.
Asian languages like Chinese, Korean, and...
We are doing, we tried with Chinese, standard Chinese, and we tried with another language for a use case for a client. I don't remember the name. It was a really strange name. Not all the languages have the same kind of performance, and not all the language has the same kind of support for language models, foundation language models. So if there is no foundation language models, it's complex on that language.
No more questions? Okay, thank you.
Thank you.